Hi students, hope you all fine. Okay, so again I came with one more problem. So that is nothing but confidence interval. So we have calculated many problems in this. Those who are following my videos, they will understand. So this is also requested by a student. So please, if you want any topic, please comment so that I'll try to make the video. Okay, yeah, let's see. Derive the confidence interval for the proportion. Okay, proportion they are asking of a binomial population. Okay, so first what we have to do is we have to write the confidence interval. Okay, the confidence interval for the population proportion P, proportion is denoted with P, is given by see here population proportion, no, so that's why capital P. If it is sample proportion, then we denote with small p. Okay, is given by confidence interval equals to P plus or minus Z alpha by 2. Okay, square root of P into 1 minus P by N. Okay, so binomial in the sense what? PQ, no? Binomial, in binomial we come across the terms PQ. So that's why by using binomial we get this only. Okay? Yeah, next, where P equals to small p equals to sample proportion okay. Next, capital P equals to population proportion so in confidence interval we use small p. Okay, don't confuse. So next, Z equals to Z score, that means nothing but critical value. Z score, nothing but critical value, level of significance. Okay, next, N equals to sample size. Okay, yeah, and the next is what they asked us to find out, derive they asked. So that's why what we have to do is first we have to calculate P equals to X by N. Okay, P equals to what? X by N. This is small p ma. P equals to X by N. And the next we have to determine what? Next second step is determine Z score. Z score in the sense what? Level of significance. Okay, and the next calculate confidence level. We have to calculate what? Confidence level. And next what we have to do? We have to calculate confidence limits. Okay, and the next is to find interpretation we have to find, that means what? Lower limit and upper limit. Okay, so see here, this is called as confidence interval. Okay, this whole term is called as what? Margin of error. Okay, only this term is called as what? Standard error. Okay, SC. Okay, so like this we have to derive the confidence interval formula. See here we fix the level of significance. Here we calculate the confidence level. Okay, now that means at Z alpha by 2 we calculate. Here limits in the sense what? This one, plus or minus we keep all the values, we keep here, and finally we calculate the values. Okay, upper limit and lower limit values we find out. So this is about what? Derive the confidence interval for the proportion of the binomial population. Okay, yeah. Next, one more question I am going to tell you. So that is nothing but, already in this model we did one sum. Those who follow my videos, they will understand. So one more problem I am going to tell you. Yeah, a random sample of size 20. So that means what? Here they give sample size of 20 from a normal population is found to have variance 0.2. That means what? Population is having variance 0.2. Find 99% confidence interval. So they are asking us to find out 99% confidence interval. Okay. So if you watch my previous video, when population variance comes, at that time we use what? Chi-square distribution confidence limits. Okay, chi-square distribution. Okay, you check in my previous videos. Okay, you will understand. Let us solve this one. So confidence, first we will write the formula. Okay, na? So confidence interval formula is given by n minus 1 into s square by chi square 1 minus alpha by 2, comma n minus 1 s square by chi square alpha by 2. So this is the formula in order to calculate confidence interval when we come across population variance. Okay, now we'll write the data which is given in the problem. So given that, so sample of size what? So sample size how much? Sample size equals to 20, isn't it? Sample size 20, and the next is next variance. Okay, variance. So variance s square equals to 0.2, and the next is okay, this much they give, and they are asking us to find out what? 99% confidence interval. Here we use what? N minus 1 degrees of freedom, no? So that means what? N minus 1 in the sense what? N minus 1 is nothing but 20 minus 1, that equals to 19 degrees of freedom we are going to use. Okay, yeah. Let us calculate. So first we will calculate chi-square. Here they give alpha equals to 99%. 99% is also called as what? 1%, or we can also call as 0.01%. 01, not percent, 0.01 also we can say. So now what we have to find is alpha by 2. So alpha by 2 equals to how much? Here 0.01 by 2. So 0.01 by 2 is nothing but 0.005 we will get. So let me show you. So 0.01 divided by 2. 0.005, no? So 0.005. Okay, and next what we have to calculate is 1 minus alpha by 2. So 1 minus alpha by 2 equals to 1 minus 0.005 is nothing but how much we will get? 0.995 we will get. 1 minus 0.005 equals to 0.995. 0.995. Okay, so these values now we have to find out, table values. Okay, yeah, the critical values at chi-square 0.05, sorry, 0.005 with 19 degrees of freedom is 36.191. Okay, so this is 36.119. Next, the critical values are nothing but table values. The table values at chi-square 0.995 with 19 degrees of freedom is nothing but here 8.906. So these are the critical values. Two-tailed, you have to observe table values at two-tailed. Okay, two-tailed you have to observe. So now we will substitute in this. Okay, so n minus 1 in the sense what? N minus 1 in the sense 20 minus 1 s square in the sense what? Here 0.2 into 0.2 divided by chi-square 1 minus alpha by 2. Chi-square 1 minus alpha by 2 value is nothing but 0.005. So that is nothing but 8.906, comma, again 20 minus 1 into 0.2 by 36.191. So now we are going to calculate this. So see here, 20 minus 9 is nothing but 19 into 0.2. Sorry, 19 into 0.2 equals to 3.8 divided by 8.906. So that equals to how much? 0.4267. Okay, so 0.4267. 4267. Yeah, and the next is again 19 into 0.2 equals to how much? 3.8 into 36.191 equals to, sorry, 19 into 0.2 equals to 3.8 divided by 36.191 equals to 0.1050. Okay, so these are the confidence limits. Okay, so these are the confidence limits for what? Population variance. Okay, these are the confidence limits for population variance. Okay, and next one more problem we'll see. That is nothing but, so on confidence interval itself, a random sample of size 17. Okay, so they gave sample size 17 from a normal population is found to have a sample mean. So that means they gave sample size, sample mean, and sample variance also they gave. So obtain 90% and 95% confidence interval for the mean of population. So see here, for calculating mean, we are having two methods. One is normal distribution, z-test, and the other is t-test. But here we are having sample size 17. That means it is small sample. So we have to use which test? T-test. Okay? Yeah. First, given that, so given that sample size n equals to how much? 17. Next, sample mean how much? 4 point, that means x bar equals to 4.7. Next, sample variance. Sample variance is denoted with S square equals to 5.76. Okay, so now we have to calculate what? 90% and 95% confidence interval. Okay, first we'll write the formula. Okay, so to calculate confidence interval for the mean of population, we use the following formula. Okay, following formula. So that is nothing but confidence interval equals to x bar plus or minus T alpha by 2 into S by root n. Okay, so this full term is called as what? Margin of errors. Only this term is called as what? Standard error. Okay, yeah. So now we are going to calculate at 90%. At 90% we are going to calculate. So at 90% in the sense what? Nothing but we can say it as 10%, or else we can also say that 0.10 also we can tell. Okay, yeah. Alpha equals to now 0.10. Alpha by 2 equals to how much? 0.10 divided 2 equals to 0.05. Okay, so the critical value at t 0.05 with n minus 1 degrees of freedom. N minus 1 in the sense what? 17 minus 1, that means 16. With 17 minus 1 degrees of freedom equals to here 1.746. Okay, two-tail test. It is a two-tail test. We have to see two-tailed. Two-tailed table values you have to see. Okay, so now we will calculate this. Okay, so x bar in the sense what? 4.7 plus or minus T alpha by 2. T alpha by 2 in the sense what? 1.746 into here s in the sense what? Square root of, here s square, no? So we want s in the sense root of 5.76. So that is nothing but we will see. So square root of 5.76. Sorry, square root of 5.76 equals to how much? 2.4. So here s value is nothing but 2.4. So yes in the sense what? 2.4 by root n. Root n is nothing but 17. Okay. So now we will calculate this one. 4.7 plus or minus, first we will divide these two terms. 2.4 divided by square root of 17. 0.5821 into 1.746. 1.746, that equals to how much? 1.0163. Okay, so now what we have to do? Once we'll check it. So 2.4 divided by root 17. Divided by root 17 in the sense what? 0.5821 into this term into 1.746. So 1.0163. Now we have to write into two terms. That is nothing but 4.7 plus 1.0163 comma 4.7 minus 1.0163. Okay. So we'll do 4.7 plus 1.0163 equals to 5.7163 comma again 4.7 minus 1.0163 equals to 3.6837. Okay, so the confidence limits are these both. Okay, now upper limit, this is lower limit, this is upper limit. Okay, so the confidence interval lies between these two values at 90%. Now we are going to calculate what? At 95% we will calculate. 95% only they gave now in question? Yes. So at 95%, or we can say that 5%, or else we can say that 0.05. 0.05. So now alpha equals to how much? 0.05 comma alpha by 2 equals to how much? 0.05 divided by 2 is nothing but 0.025. Okay, yeah. The critical value at two-tailed, okay, don't forget two-tailed T 0.025 with 17 minus 1 is nothing but 16 degrees of freedom equals to how much? This is a table value, okay, 2.120, okay. Here 1.742, here this is a table value 2.120. Okay, now we will substitute in this formula. X bar in the sense what? 4.7 plus r minus t alpha by 2 in the sense this value 2.120 into s by root n. S in the sense what? 2.4 divided by root 17. Okay, so 4.7 plus r minus 2.4 divided by root 17 equals to 0.5821 into 2.120. So that equals to how much? 1.2340. Okay, so we will divide into two parts. 4.7 minus 1.2340 comma 4.7 plus 1.2340. Okay, yeah. 4.7 minus 1.2340 equals to 3.4660 comma 4.7 plus 1.2340 equals to 5.9340. So this is lower limit, this is upper limit. Okay, so these are the confidence limits at 95%. Okay, hope you all understand. So if you want any video, please comment. If you are newly watching, please subscribe to my channel, share with your friends, and also like. Thank you for watching. Have a nice day.